Hi everyone, Assalamualaikum. Welcome back to another lecture video. In today's video, we're going to learn a new topic, confidence interval. Confidence interval is also known as interval estimates. Now, to know what interval estimates are, you need to know what point estimates are first. Recall from the last topic, we learned how to calculate samples. Now, once we've collected our samples, we can use data from our sample to estimate characteristics of the population. Okay, so basically a point estimate is the value computed or calculated from our sample data in order to estimate the population value. Let's take a look at this table. Focus your attention on the first column. From our population, we'll be able to get our population mean, our population variance, population standard deviation, as well as population proportion. These are the symbols used in order to denote these items. Okay, but as I mentioned to you before, sometimes it's just not possible to get information from the entire population. That is why we collect samples. Okay, now from our samples, we can also calculate our average or sample mean from that sample. We can also calculate our sample variance. We can get our sample standard deviation as well as sample proportion. These are the symbols that denote what I just mentioned just now. So basically, when we calculate our mean or average from the sample, which is x bar is actually an estimate of the mu that we are actually interested in. Likewise, sample variance or S squared is the estimate of sigma square or population variance that we are actually interested in. Sample standard deviation or S is the estimate of sigma that we are actually interested in. As well as sample proportion or P, it is an estimate of the pi or population proportion. Now, all of these are known as point estimate. Point meaning there's only one value calculated from the sample. Okay, so the process of us calculating our point estimates in order to estimate the population parameter, the process is called point estimation. Let's illustrate. Say this is our population. Okay, this big circle is our population. From our population, we'll be able to calculate our population average or mu. Okay, which means we just add all of the values from the items in our population and divide by the total number of the population size, mu. However, as we've learned at the beginning of last topic, it's sometimes impossible to collect information from everyone or everything in the population. Therefore, we collect samples instead. From our sample, we can also calculate the average, which is the sample mean or x bar. And we've also learned in the last topic, x bar is not usually equals to mu. The difference between the population parameter or mu and the sample statistic, x bar, is called the sampling error. Now, x bar or sample mean is our point estimate. Why is it called a point estimate? Because it is only one value calculated from the sample. Now, as we know, our x bar is not usually the same as mu. There's a difference, right? Called sampling error. So how can we say that this point estimate is a good estimate of the true population parameter? That is why in practice, it's very rare we just rely on one value or point estimate. See, so x bar is our point estimate. So it's very rare that we only rely on x bar to estimate the value of mu. Instead, what we do is, from that one value, we come up with a range of values. Okay, so this range of values are called the interval estimates. Okay, let me give you an example. Say a crime happened and you happened to be the witness. So the police ask you, what is the height of the criminal or the suspected criminal? So it's very rare that you would say, oh, the criminal or the bad guy is 175 centimeters. Because when you tell the police that the criminal is 175 centimeters, you are giving a point estimate. Because normally crimes happen very fast, so we're not really sure. So we usually tell the police, I think the criminal is about 175 centimeters, because when you put the word about, it means you are giving a range. The criminal could be 170, the criminal could be 180. So that's the difference between point estimate, which is 175 centimeters, or an interval estimate between 170 and 180 centimeters. So it really depends on what we're interested in. If we're interested in finding the population mean, or mu, we use the x bar to calculate the confidence interval to estimate the mu. If you're interested in finding the population proportion, or pi, we use the sample proportion, or p, to calculate the confidence intervals in order to estimate the population proportion. Now let's look at the first case. If you want to construct or calculate the confidence interval for a population mean, there are two things you need to consider. The first is the size of the sample, or sample size. Is the sample size large? Large meaning n is at least 30, okay? Or is the sample size small, less than 30? The second thing we need to consider is if we know the population standard deviation or not. Okay, so these are the two very important considerations to make when we want to construct or calculate the confidence interval for mu. Now, usually, when the sample size is large, we know the population standard deviation. Okay, so now let's look at how to calculate the confidence interval for mu, given that the sample size is large and the population standard deviation, or sigma, is known. Do you remember this illustration just now? X bar is our point estimate. What we want is a range of values originating from that point estimate, called the confidence interval, or interval estimates. Now, I want you to visualize this. We have a point. From this point, we want to plus and minus a certain value so that we'll be able to get these two limitations. Okay, so this is called the upper limit and lower limit. Together, it gives us a range of values called the interval estimates. So we begin with our point estimate, which is x bar. Now remember, we want to create a range or an interval, right? So that's why we need to plus and minus here. We need to plus a value and we need to minus some value from the sample mean. Okay, again, I repeat, sample mean is our point estimate, plus minus something. And now that something is called the margin of error. Okay, now margin of error consists of two parts. One is the confidence level. Okay, the second part is the standard error. Now, you've already learned these two concepts in previous topics, okay? Confidence level is basically the Z value. Remember Z? I'm sure you know how to find the Z value from the normal table by now. And the standard error, we've also learned that in the last topic. Standard error is basically the standard deviation for the sampling distribution of sample mean. So what is the standard error? Remember, it's standard deviation divided by the square root of n. Okay? So now, let's put all these three together because now it looks a bit chaotic. Okay, so the formula to find confidence interval for mu, okay, is basically the point estimate plus minus Z times the standard error. Okay, so this is the formula, which is actually available in your textbook and lecture notes. Okay, I was just explaining to you, okay, the breakdown of this formula. Now, sometimes we don't know what the population standard deviation is, even when the sample size is large. So what do we do in that instance? Very simple. If, let's say, we have a large sample size, but we don't know what the population standard deviation is, all we need to do is just estimate the sigma with the sample standard deviation, or S. In other words, you can rewrite the formula as the point estimate plus minus confidence level times S, or sample standard deviation, over the square root of n. Since we use x bar, or the sample mean, to estimate mu, we can also use the sample standard deviation, or S, in order to estimate the population standard deviation. So remember, whenever we don't know what the population standard deviation is, we can just use S as the substitute for it. Okay, let's take a look at your lecture note and summarize. Okay, when we want to calculate the confidence interval for a population mean, okay, in the case of a large sample size and we know the population standard deviation, this is the formula that we use, see? Okay, so the point estimate plus minus confidence level, or Z, times the standard error. Okay, and since we know the sigma, so we just put sigma here. However, in the event that we do not know what the sigma is, all you need to do is substitute the sigma with S. Okay, but in either case, the sample size is large. Remember that when the sample size is large, we can adopt the central limit theorem in that we can assume that the distribution of the sample approaches normality. So when we assume that, we can use the Z distribution. Okay, let's take a look at an example. How can we calculate the 95% confidence interval for mu? Take note, here they already give you the confidence level. Okay, 95% is confidence level. So why do you think they gave you this? They gave you this, which is a probability, in order for us to estimate the Z value. Okay, remember, 95% is the confidence level. Z is the confidence level. Okay, so you may remember by now how to calculate Z, right? Given the probability. In case you've forgotten, here. Okay, let's say this is our normal distribution. So from here to here is 95%, right? So we want to know what is Z. So what we need to do is we take 95% and divide it into 2, divide it into half. So each side will have 0.475. Here also 0.475. Now we take our normal table. Okay, look in the body or inside, because remember, all the figures outside are Z. Everything inside is probability. What you have here is the probability. We want to know what Z is, so we're working backwards, okay? So here is 0.475. What is the Z value? 1.96. Oops. There, okay? So 1.96. Therefore, our Z values are 1.96 on the right and minus 1.96 on the left. Now with practice, you don't really need to show the workings on how you get the Z. In fact, if you do a lot of practice, you'll be able to memorize it already. So here in your lecture notes, I've already given you a summary of the popular Z values or popular confidence levels. So if you're given a 95% confidence level, we know that the Z value is 1.96. If the confidence level is 99%, it's 2.58. So these are basically the shortcut, okay? But just in case, if they give you other confidence levels, maybe 92% or 89%, you still need to know how to calculate your Z values, okay? See, this is our normal distribution, okay? Right, so this is our all of our X bar values. So here in the center here would be our X bar, okay? In fact, everything is X bars. It's just that we want to find the one in the center. Okay, so now X bar here is our point estimate, right? But we don't want to use one point estimate. We want to come up with a range of values. So we want to come up with this range of values, say. Okay, so this is our range of values. Okay, so from here to here, let's say if they ask us to find the 95% confidence interval. Okay, let me just write down. We are finding the 95% confidence interval for the population mean. Okay, what it means is this is our point estimate, X bar, plus minus something so that we can have the interval estimate or confidence interval. Plus minus what? Remember just now? Plus the Z times the standard deviation over the square root of n, and here point estimate minus the standard the confidence level times standard error. Okay, so this is what it means. Okay, remember the formula just now? To get the confidence interval is basically the point estimate plus minus margin of error. Margin of error consists of two things, the confidence level and the standard error. So this plus minus simply means we're adding to one side and minusing the other side. So this value is basically our value here. This value is our value here. This is how you want to sketch or visualize what it means to calculate 95% confidence interval for mu. Now, of course, it doesn't have to be 95% all the time. As I mentioned to you, it could be 99%, 98%, 90%. So of course, whatever it is, the confidence level given to you, you adjust the Z values accordingly. Just in case you're a bit confused, confidence level is the probability given to you, okay? The Z values. Confidence interval are these 2 points, okay? Bear in mind, they're different. Confidence level is not the same as confidence interval. Okay, besides knowing how to find the Z values, another important thing you need to know is how to interpret the confidence interval once you've done calculating or constructing them, right? Okay, so how to interpret is very simple. Now remember, the whole point of this exercise is for us to come up with a range of values so that we can, guess or estimate what is the mu, right? So what we want is, we want to make sure that this mu, okay, by constructing this interval, we want to see whether this mu is or lies within this interval. So how do we interpret? One of the popular interpretation, and the simplest one, is you can just say that we are 95% confident that the true value of the population parameter lies within the interval this and this, okay? Of course, I've also given alternative interpretations here in the lecture notes, which are also in the textbook. Again, if you don't have any of them here, I'm showing it to you so you can maybe screenshot and freeze it and read. Okay, and there are also, of course, the ebooks that I've uploaded in the class website. You're free to use those resources, okay?